This module on wave refraction will help you with this part of the assignment. As waves come into water shallower than the wave base, which is defined as a depth of half the wavelength, the orbital movement of the waves begins to feel friction with the bottom, and the waves begin to slow down. The shallower the water gets, the slower the waves go. As they get into shallower water, they bunch up together, grow taller, and eventually break. But the other thing that the waves do before they even break is what's called refraction, which is the waves bending and changing direction as they slow down in shallow water. Here's an animation that shows wave crests coming in straight to the beach. And what I want you to imagine here is that off of the headland where the lighthouse is, the water here is probably shallow, whereas it's deeper over here in these two bays on both sides. So the waves slow down more here and less here, and that causes refraction. You can see how the waves are bending and changing direction. Now the reason this is important is that if we put arrows on the waves showing how their energy gets directed, the refraction causes the energy of the waves to be concentrated in the shallow water near the headlands where the waves wrap in and push together. So you're going to see the biggest waves and the most erosion right here, whereas the energy of the waves gets spread out in the deep bays on both sides. So the energy here is dissipated, and here you're going to see kind of small waves. Now this process of refraction of waves bending in over shallow areas is very important for forming big surf waves. And we're going to look as a case study at the Mavericks wave in Northern California near Half Moon Bay. Pretty good picture of me here on the Mavericks wave. Yeah, right. Mavericks is a really marvelous wave. It only gets going a few times a year, but when it's on, it's ferocious, and it's a world famous wave. This picture shows what's sometimes thought to be the world's greatest wipeout. Jay Moriarty wipes out at the top of the wave and falls more or less 60 vertical feet through the air at the bottom of the Mavericks wave. Mavericks is located south of San Francisco, right here off a point of land near Half Moon Bay in central California. What I want you to do now is go look at the video called The Science of Big Waves that is going to explain for you, among other things, why there's a big wave that forms here at Mavericks. The key is refraction.